Here we go, a few examples of permutations and combinations. So starting off with a bag that has 3 red, 7 blue, 6 green, and 4 white marbles. How many ways are there for you to pick 5 marbles out of the bag? Now, this is not telling us that we're going to take a marble out, look at it, and put it back. So therefore, this is what's called it's not called what with replacement. That would be with replacement, where if you take it out, look at it, and put it back. If they don't tell you that, then the assumption is we're just pulling out 5 marbles. And kind of the nice thing is you can either do one at a time, or you can do 5 at once. Probability wise and counting wise, it's the same thing. It doesn't make a difference. So whatever, I personally think for most scenarios, it's easiest to think of it as 5 at once if it's a combination. If it's a permutation, if the order matters, then the one at a time is kind of important because you have to say first, then second, then third. But if it's a combination, then we just pull all 5 at one time and you're good to go. So let's take a look at this. Now, this one, is it saying anything about ordering? Is it saying anything about, well, if you get a red marble first, then this, or if a blue marble first, then that? No, it's not. It's just saying how many ways are there for you to get 5 marbles. So that implies to me that it doesn't matter the order. It's just telling us, tell me how many reds, how many blues, how many greens, how many whites you had when we pulled out our 5. So therefore, I'm going to call this one a combination. So therefore, filling in our combination notation, I'll use the calculator notation. Let's see, how many marbles are there total for us to pick from in the bag? Well, let's see, 3 red, 7 blue, so that's 10, 16, 20. I see 20 marbles. And out of those 20, we're going to choose 5. So therefore, you could do this by hand, but I will tell you right now, I am never going to require you to do this by hand, so you can do every single one of them in the calculator. But you never know. Another teacher may require you to do it by hand, so make sure you know how to do it using the formula. So let's see, this would be, there's our answer. So when we do this, whoops, go over there, don't come back. All right, so this turns out to be 15504. So that means there are 15,504 different ways of taking 5 marbles out of a bag of 20 marbles. Pretty cool. All right, great. The hardest part of this, what's the hardest part of this? Just identifying if it's a combination or a permutation, right? Okay, a bag has 3 red, 7 blue, 6 green, 4 whites. How many ways are there for you to pick 5 marbles out of the bag, given that exactly 1 marble is red? All right, this is called harder. No, so the idea here, I always call this a condition. Okay, we know it is given that we have 1 red marble. You are going to get 1 red marble. So you can kind of think of this in a series of different ways, and we actually get to a section called conditional probability where we'll take another look at this in a different angle. But for now, what we're going to do, how I take a run at these is I always say take care of your condition first. Okay? So what that means is, remember, we are not mortals. We are not, nothing is random, nothing is to chance. We pretend you are some higher power that has control of everything. And if you are looking down and you say, I am going to guarantee that they get a red, okay? Or in whatever voice you would imagine your higher power having. Okay, so first we have a decision. Let's first take care of their red marbles. Out of those 3 red marbles, we need to give them 1 of them. We're going to put 1 of them in their pile. So now, is that a permutation or a combination? Well, it's just a combination. We're just going to say out of our 3 red marbles, we're going to choose 1 of them. Okay, once that decision is done, now we have other decisions to do. We have other marbles to put in their hand because they need to have a total of 5 marbles, right? 1, 2, 3, 4, 5. And I have chosen, all right, that one's a red one. Okay. Now, another thing that you might be saying is, well, a red is red, right? It doesn't matter which red I give them. Well, probability says there is no such thing as indistinguishable dice, marbles. They're all distinguishable. You have to imagine that each marble on it actually has a label, and maybe this is red 1 and this is red 2, and this is red 3. And you could imagine from a human perspective of, maybe this one has a little chip in it, and this one has a little bubble on the inside of the marble, and who knows, and that one looks perfect. So you can actually tell the difference. Even though they're 3 red marbles, you can tell the difference. So out of our 3 marbles, we're going to pick one of them. It's either red 1, red 2, or red 3. So there's 3 different ways we can pick a red marble. Then, out of our other marbles, how many other colors are there? Well, there's 7 plus 6, so that makes 13, plus 4, so that makes 17. So out of our 17 other colors, we're going to choose 5 marbles total, so I'm going to choose 4 of those. Now, the logic here, the thing you have to understand, we can't include the other red marbles. This can't be 19 choose 4, because the problem says we need exactly 1 red. And because of this part right here with the red, we've guaranteed they have 1 red and they have exactly 1 red. And if I put the other red marbles in here to choose from, then that means they could accidentally get 2 red marbles. We don't want that. So we're going to do we have 3 red marbles. We're going to pick one of those. We have 17 not red marbles. We're going to choose 4 of those. And then that takes care of our decisions and choices. Chapter 6.3 coming back. Or the counting, adding and multiplication principle coming back. We have decision 1, pick red marbles. Decision choose 2, pick other marbles. And then take those. Multiplication principle says multiply them. So therefore, what is 3 combinations 1? Well, in your calculator, that'll tell you it's 3. Or logic will tell you it's 3, because out of my 3 things, how many ways is there for me to pick one of them? Well, I either pick the red 1, red 2, or red 3. 3 choices. Okay. The other one, 17 choose 4. Logic's not going to help me there. We're going to actually have to use our handy dandy calculator. So here we go. 17. Arrow over to probability, NCR. 17 choose 4. That gives us 2,380. And that gives us a total, go away marbles, of times 3. 7,140. Now, you'll notice these were essentially the same problem, same sets of marbles, same number of marbles. What's the difference? Well, this one has less options. Does that make sense? Well, sure. Problem 2, we were just saying there was no constrictions. There were no conditions. It was just how many ways are there to get sets of 5 marbles, whether they have reds or blues or whatever. It doesn't matter. So there are 15,504 different possibilities. Now, if we're going to limit that down, though, and say they have to have a red marble, well, then we're going to have less options. Now we're only going to have half as many, about 7,140. Okay, so let's do one more marble problem, and then we'll move on to the next video to another type. All right, so now, this problem says, all right, let's see, is it the same bag? 3 reds, 7 blues, 6 green, 4 whites. Looks like the same bag. Now, how many sets of 7 marbles, not 5 anymore, 7 marbles that contain all the green ones? All right, so I want you to pause the video and try this yourself. All right, here we go. Take care of your condition first. What is the condition? Well, the condition is we must have all the green marbles. So how many green marbles are there? Well, let's see. There are 6 green marbles. So taking care of our green condition first, out of my 6 green marbles, I need to choose all 6 of them, and the order in which we pick them is not important. That takes care of the greens. I don't like that 6. It's going to bother me. Okay, then I need to fill in any other color. So how many marbles are remaining? Well, if there's a total of 20 marbles in the bag and 6 of them are green, that means there are 14 other marbles. And out of those, how many do I need? Well, if I'm picking 7 marbles and I know 6 of them, I already used 6 to be green. That means there's 1 left for me to pick there. So therefore, here we go. 6 combination 6. If there are 6 green marbles and I need to choose all 6 of them, there's 1 way for me to do that. I pick all of them. And then 14 combinations 1. If there are 14 other marbles and I pick one of them, there are 14 ways for me to do that. So there are a total of 14 different combinations of marbles that have 6 greens and 1 other when I'm picking 7 marbles. Okay, I hope this was a marble-rific video, and I hope I'll see you in the next one.